So now we'll look at two of what I call the trickiest trinomials, which simply means that the numbers are starting to get larger. I'll look at 3 different ways to solve these problems. Pick your favorite. Maybe you're already familiar with one of these, or maybe for some questions, a different technique will help you. Either way, as long as you get to the factored answer, they're all fair game. I know there are many more options out there as well. All right, so looking at this one question. First thing I notice is that while it's a trinomial, it's not in the order I expected it in. I expect the x squared term to show up first. I expect the terms to be in descending order of power. So the very first thing I'm going to do is simply rewrite it as 12x squared plus 4x minus 5. Remember that I can move terms around as long as I keep their signs with them. So it's a positive 12x, a positive 4x, and a negative 5. All right, so now it should look more familiar. And I know the format of the answer for a trinomial like this. It will look something like this. I've got 2 binomials multiplied together. Because my x squared term is first, I know that the first term in each binomial, in each factor, will have an x. And I will have 2 terms in each factor. Now I need to look at how I'll first get to the 12 and the negative 5. So I'll look at 12 and 5 and make sure I know all the factors I could use, all the combinations. 5 is the easy one. 1 times 5 is the only way. It's nice when we have a prime number, as we saw previously. Because it's a negative 5, I know that I'll have either negative 1 and positive 5 or positive 1 and negative 5. I'll keep that information in my mind. What are all the options for 12? You can probably list them, but if you're stuck, here's one way to make sure you get all of them. Divide 12 by 1, then by 2, then by 3, then by 4, until you start repeating. 12 divided by 1 is 12. So our first option is 1 times 12. 12 divided by 2 is 6. 12 divided by 3 is 4, so 3 times 4 is 12. 12 divided by 4, oh, we already have that option. So we have all of them here. Okay, so if we're using the guess and check method, this is a lot of options to try. We'll have to try each of 1 and 12, 2 and 6, 3 and 4, with 1 and 5 or 5 and 1. I'm not going to draw all of those out. But I am going to remind you that we want to look at the outside 2 terms and the inside 2 terms. That's how we're going to get to this positive 4x. So this is where we start worrying about the positive 4. We know what numbers we're allowed to use. They're listed below, under the 5 and the 12. It's the combination that's tricky to get to this middle term. So I know it'll be 1 and 5. I'm keeping that in mind. And I can start looking at it. What if I use 1 and 12? Well, maybe I have 1 times 1 and 12 times 5. Well, that's ridiculous. That 12 times 5 is 60. Those like terms will never sum to positive 4. Even if I flip them around, 12 times 1 and 1 times 5, I'm way off base. And I'll think that through for each of them. Which one do you think it is? Turns out it's 2 times 6. We'll use that one first. So let's try 2x and 6x. All right, so that has to be matched with 5 and 1. And I'm going to match the 2 and the 5 as the outside 2 numbers, and the 1 and the 6 as the inside 2 numbers. Once I do that, I see I get 2x times 5 is 10x, and 1 times 6x is 6x. And if 6x was negative and 10x positive, I know that that gets me to positive 4. And I expected that to happen. I looked at the 2 and the 6 and the 1 and the 5 and thought, ooh, if I had 2 times 5 and 1 times 6, the difference is 4, that could work out. So I tried it. So I'm thinking about this outside and inside when I'm just looking at the pairings. And then I'm checking. So a little bit of guess and check is absolutely going on here. I'm not quite done because I don't have the signs. I need the 10x to be positive, and I have a positive 2x, so I need a positive 5 to multiply it by. And so I already know the other one will have to be negative in order to get the negative 5, this final term. But I also see that I need a negative 6x, and I have a positive 6x, so it makes sense that the 1 is negative. Now, of course, feel free to FOIL it out. This is the correct answer, but multiply it out to make sure that it matches our original. If your options are too numerous here, it can get a little bit daunting, but with practice, you'll find it quite easy to narrow it down. Factoring is certainly one of those topics where it seems quite challenging at first, and then once you get it, you can factor anything. But it has a little bit of a steep learning curve. I'll show you 2 tricks that a lot of people use. And sometimes that just helps you learn this method. This tends to be the fastest, but there are absolutely other options. This next one is called the diamond method. Sometimes called the product sum method. Product sum seems to refer to a number of different methods, and it relies on the same ideas. So the next 2 methods will both rely on some multiplication and some addition. So what are we doing? So let's do the diamond method first. So I'll write a big X. This is our diamond. See a couple diamonds in here. You need a bit of an imagination for this. Now I'm going to take the first term, the coefficient of the first term, I should say, the 12, and multiply it by the last term. That's the product part of product sum. 12 times negative 5 is negative 60. And I'll write that number up here. Underneath, I'll write positive 4, the middle term, the coefficient of the x. So if we set it up this way, the next step will always be the same. The next step is the leap of faith. I need you to find 2 numbers that multiply to give negative 60, but add to positive 4. You'll find that the only options are positive 10 and negative 6. You can write them in any order. We've seen a positive 10 and a negative 6 before, negative 6x and positive 10x. So this shouldn't be a surprise, and it's certainly not a coincidence. So what we found are those middle 2 values. How do we find the numbers 2, 1, 6, and x? Let's keep going. So that was the tricky part, finding the 10 and the negative 6. It may have taken you some time to come up with that. One thing that could help is writing out all the factors of 60, 1 times 60, 2 times 30, 3 times 20, and so on, and finding a pair there. But in any case, once we have these, the steps are always the same. You're going to take the 10 and the negative 6, take both values, and divide them by the coefficient of the first term. The coefficient of the first term is 12, so I'm going to divide both by 12. Once I have those 2 fractions, I'm going to simplify them. 10 over 12 simplifies, because both are divisible by 2, to 5 over 6. And negative 6 and 12 both divide by 2, so I get negative 1 and 2. Maybe you recognize these numbers now. The 5 and the 6 end up in one bracket as 6x plus 5, and the negative 1 and the 2 is 2x minus 1. It's always going to work out that way. You'll notice too that it will always be the 5 and the 6, the numbers in the same fraction that end up in the same bracket. Because we divided by the coefficient of the first term, it's the 6 and the 2 that will have the x's, 6x and 2x, as you can see. So just to write a complete answer, this will also be 2x minus 1 times 6x plus 5. Or of course, you could write that as 6x plus 5 times 2x minus 1, as it means the same thing. One caution here. You must have removed any common factors before starting this. So I'll write this down here. Don't forget, common factoring has to come first. So don't forget about common factors. Because we're reducing the fractions, this will automatically take out essentially any common factors. So your answer won't match your question if you haven't thought ahead to that. So don't use the diamond method until you've already removed common factors. Now here's one final method. I'll write the question one more time in the reorganized form. So 12x squared plus 4x minus 5. We're still interested in the product of the first and the last term, and we're interested in adding to get to the middle term. So we're looking for two numbers whose product is the product of the first and the last term. Okay, so our product that we're aiming towards is negative 60, and those numbers will have to multiply or add to give us 4. So we're asking the same question that we previously asked over here. What two numbers will multiply to give you negative 60, but add to give you positive 4? And the answer is still going to be 10 and negative 6. So we know that 10x and negative 6x gives us the 4x. So we're going to substitute 10x minus 6x in for the 4x. Okay, so we get 12x squared. And then in the middle, instead of writing 4x, I'll write plus 10x and minus 6x. That's equivalent. And then finally, I'll put in the last term, negative 5. Okay. Now I'm going to do a little bit of magic. I'm going to notice that I can group these. I have 12x squared plus 10x, and they have some things in common. And then I'm adding the second bracket, negative 6x minus 5. So be careful here with the negatives. When you bracket off the negative 6x and the negative 5, should you leave the negative in the middle, you'll have to change the sign for the 5. So I've decided just to keep negative 6x and negative 5 the way they are and recognize that I'm adding those two. Just make sure your two lines are equal. Looking at this first one, the first set of brackets, we're going to remove a common factor. What's the common factor of 12x squared and 10x? Well, they're both divisible by 2 and by x. So I'm left with 6x plus 5. Looking at the second set of brackets, what do they have in common? Negative 6x minus 5. Well, I'm going to pull out that negative 1 because when I do so, you'll notice that I have 6x plus 5 left over in both terms. So the goal here is to engineer exactly that, to have a 6x plus 5 and a 6x plus 5 in both terms. Remember that there's actually a negative 1 hanging out here. So now what we're doing is looking for the common factor. I have two terms globally. What do they have in common? The 6x plus 5. So I'll pull out the 6x plus 5. And when I do so, what's left from the first term? Well, the 2x. What's left from the second term? The negative 1. And you see you get the same answer as we did in the previous two attempts.